Hi, this is Mr. Max. So I am doing one particular very interesting question. We come across this 0 factorial when we are dealing obviously with binomial theorem. So I just thought it's going to be interesting to know or to kind of somehow prove why is 0 factorial equal to 1. Could be confusing. Alright, so I have got two scenarios here. So here I've got base 3 and the powers of such, so 3 raised to the power of 0, 3 raised to the power 1. Very interested in finding a pattern that holds. Now we know that 3 raised to the power of 5 is actually equal to 243. 3 raised to the power of 4 would be 81. 3 cubed will be 27. 3 squared will be 9. 3 raised to the power of 3, or 3 raised to the power of 1 rather, is 3. And we know by convention that we have decided upon all these laws that 3 raised to the power of 0 is equal to 1. But let's see what actually that entails. If you take 243 and you divide it by 3, you get 81. So I'm working my way backwards so I can get the pattern. And if I take that 81 and I divide it by 3, I get 27. And if I get that 27, I divide it by 3, I get the 9, which is equivalent to 3 squared. And I get that 9, I divide it by 3, I get 3. So we shouldn't have to stop there. So 3 raised to the power of 0 is the same as n3 divided by 3, which gives you that 1 there. Alright? And so you can continue with negative 1 and so on. 3 raised to the negative 1 and so on. But that's where I'm going to stop for now. So I'm going to use this very same reasoning here. Alright, so I hope that you know that 5 factorial is the same as 5 times 4 times 3 times 2 times 1, which gives you 120. So I'm going to reverse also this process the same way that I was reversing when I was doing the basis of 3 there. Alright, so 4 factorial is 4 times 3 times 2 times 1, which is 24. 3 factorial is 6. 2 factorial is 2. And 1 factorial is 1. Okay, so we're going to bring in 0 factorial later. So how do I go then from 120 to get to this 24? Yes, you take your 120, which is the same as 5 times 4 times 3 times 2 times 1, and you divide it by 5 in order to get the answer there. Okay, because you're going to realize that you're going to get 24. When you take that 24, now I'm not going to write the 24 again, like 4 times 3 times 2 times 1. Alright, I'm just going to take 24 divided by 4 gives me the 6 that I have. How do I get the 2? It's that 6 divided by 3. So you can see the pattern exists. So how do I get to 1? So 2 divided by 2 gives you 1. Right, we don't have to stop there then. So what is 0 factorial going to be? And why is it equal to 1? Well, continue the pattern, and it's 1 divided by 1, which obviously gives you 1 as an answer. So I hope that you realize that 0 factorial is equal to 1. Now, let's bring in some simple formula or simple way of calculating. 5 factorial divided by 0 factorial should be another way for you to realize it is 5 factorial divided by 1, which gives you 120. Okay? And then, so what that means is when you have n factorial over 0 factorial, it's just n factorial over 1, same like I did here with the 5. And n factorial is nothing but taking that number and multiplying downwards until you get 2 times 1. So suppose n was 5, becomes 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, until you get to a 1. Some other important thing also to note, when you are dealing with n, choose 0, n 0. It's written as a vector, but it's not a vector. We use this for the coefficients when we are dealing with binomial theorem. And we know that the rule is we take n factorial over 0 factorial, multiply by 3 minus 0 factorial. Now, when you do this, remember the 0 factorial from what we have now proved here is a 1. So therefore, this is the same then as 3 factorial over 1 times 3 factorial, because 3 times minus 0 is 3 factorial here, which eventually leaves you with 3 factorial over 3 factorial, which will give you a 1. So also the same condition if I take a 3 here, and I say 3, choose 3, and I want you to work it out, well, you know the answer should be 1, but what exactly does it give you? It's 3 factorial over 3 factorial, in brackets 3 minus 3 factorial, which is going to give me 3 factorial, divided by 3 factorial times 0 factorial, But we know that 0 factorial is equal to 1. So bringing it back to 3 factorial over 3 factorial, which is equal to 1. So we also know that n, 0, is the same as n choose n, which equals to 1. So once we are dealing with this, we will always find 1 in our binomial theorem.